Okay, good morning. Depending on where you are geographically, good afternoon, good evening. My name is Michael Babineau. I'm the CEO of Celero Optima, a coaching and consulting firm located just north of Denver, Colorado. We are the very close business partner of PlanetTogether's for all their sales and services for North America. We've done a number of PlanetTogether and APS implementations over the last 25 years. We're a dedicated group of people that only care about one problem. It is to make our customers on-time delivery soar to 95+% and beyond. So the agenda we're planning to cover this morning is just to do a very brief introduction about Celero Optima, what we do, who we are, very briefly. Then we're going to dive right into PlanetTogether, a live software demo. Obviously, this is a 30-minute webinar. It goes by really fast, so we will not have much time to drill into detailed functionality, but you'll get the gist of what you can do with PlanetTogether, I think, in the 20-25-minute software demonstration. I'm also going to talk briefly about high-performance flow manufacturing, which is a concept that encompasses several key best practice and concepts out there, including theory of constraints, lean manufacturing, and this model that we implement with our clients with the help of PlanetTogether allow customers to achieve very, very high on-time delivery performances with minimum inventory, the most velocity and highest turns, and very low operating expenses. So I'll explain how that works in a few minutes here. Then we'll open up the lines for Q&A. If anybody has a question that we can answer quickly. So we're planning to do that for about 10 minutes. Along with myself on this call are Scott McMartin, who's our VP of Business Development at Celero Optima, and also Ryan McMartin from PlanetTogether, who will act as the liaison between this demo and the company PlanetTogether today. So let's get going. Very brief introduction about our company. Again, in a nutshell, we are a consulting and coaching services firm helping complex manufacturing companies achieve high operational performance. So fulfill the customer's order in less time than your competition with higher on-time delivery and generating net operating profits greater than the cost of the capital. So any effort, any tool, any services you buy from us would be exceeded by the benefits, financial benefits that your company will have. So it's essentially a negative net cost, anything you would do with us going forward. As I mentioned earlier, we're a premier PlanetTogether APS implementation partner in North America. We have close to 25 years in average, our consultants, our coaches, we have experience in operations as managers, as consultants, in the field of planning, scheduling, everything included from order entry all the way to order fulfillment and shipment. Over the last 25 years or so, our consultants have worked on more than 85 successful scheduling process improvement implementations throughout the world. We really know scheduling. We know planning. We know demand management. We know scheduling very, very well. We've partnered up a while ago with PlanetTogether because we feel like they have the most advanced, most simple to understand yet powerful advanced planning and scheduling solution out there. That is why we partnered up with them. We believe that they are a necessary component to all our efforts with complex manufacturers in helping them to achieve the desired performance. Okay? So that being said, I'm going to dive right into the scheduling, the PlanetTogether software demo. Hopefully everybody can see this Gantt Charts. This is live software, obviously not your data, anybody on this call, but it is live data for a small project that we did with a manufacturing company who will remain anonymous at this time. But what you're looking at here is on the left-hand side, this is the main screen in PlanetTogether, one of the main screens where you can get a Gantt chart of your actual ongoing schedule. On the left-hand side, you have roll 1, 2, 3, 4, all the way down to roll 14, I believe. These are work centers in this particular manufacturing environment. And what you're seeing, the blocks you're seeing in the Gantt chart represent the jobs that are running on that machine. Starting today, this data is as of Monday, December 4th, so it's 2 days old. This is essentially the schedule that we were running on the shop floor on last Monday. So the smaller the block, and I can obviously zoom in here and do that. Zoom in, a couple of clicks, and we see the first shift represented by this green bar here at the bottom. First shift of the second day, Tuesday the 5th. First shift of Wednesday the 6th, which is today, et cetera, et cetera. And then you can see some labels on these jobs. I'm going to go and show you some of the data that can be shown on those labels. They can be customized, and they can show different things on these blocks or labels. So if I look at, for example, the first block here has 3 what we call labels, so 3 rows of information. First one at the top represents the product number, in this case, 14012, and the number of units we are producing in this job. As I click on this job, it is highlighted, as you can see from the blue line right there. The second label, in this case, we decided to represent the setup families in which these products are. So there is a die called D4. The length of product is 3 feet. The thickness or the gauge of the steel we're producing has a certain gauge number. The width is a certain width, et cetera, et cetera. So this is telling us that this product is in that quote unquote family and has a need buy of 12/4, which is today. The reason why this job is displayed in red is that we are starting the job at the end of the 4th, and it's going to be completed on the 5th, so it's actually late. Okay. The last label at the bottom here represents the status of the run. So in this example here, this run will last 4 hours, 54 minutes and 26 seconds, based on the standard and quantity that we're producing. And the white portions of the label represent setup time. Again, we're producing 3 products right here: 1310, 62542, and WP 2922, and we're doing a 1 setup for each job. There's going to be a way to reduce the amount of setups and produce more, be more productive on this work center. That's one of the things that we will display or will show here in a minute. So I want to show you the Gantt charts from a longer time span perspective. So I'm going to zoom out to a month, and we can see that 1, 2, 3, 4, 5, 6, up to 30 days. And every green bucket basically represents 1 production day. So we can see that based on the current needs in the system, a combination of customer orders and safety stocks, it'll take us about 5 days on roll 1 to complete the entire production run that we presented demand for. So what I'm going to do here is show how PlanetTogether behaves when you have material constraints. So I'm going to go and I've actually copied the name of the parameter here in a notepad file. So I'm going to bring that up. And right now we're telling PlanetTogether not to constrain the schedule with any raw material shortage. If we go to import mapping, I'm going to look at the material mapping, and in the constraint type that we're feeding PlanetTogether, and this data here can be coming from your ERP system, from spreadsheets, or any data that you have. This happens to be the material mapping, which has the child and parent in a bill of materials structure. So any make component that has a child, or any make component that has a raw material as a child or a purchase part, is defined in this table. We're basically telling PlanetTogether from this point on, go ahead and look at the constraint, look at the availability of raw materials and consider the earliest between the lead time or the available supply from a PO or from a quantity on hand. I'm just going to perform the import, go back to our Gantt chart, and just hit the optimize button. So I've just told PlanetTogether to consider raw material as a constraint. Hit the optimize button. Within a couple of seconds, you'll notice that a lot of jobs have stayed on 12/4, and some jobs have actually moved out to December 15th, and some of them even a little further, December 29th. These jobs are limited by the availability of raw materials in this particular model. This could be done in a live scenario or a what-if scenario. I'm going to show you how you run a what-if scenario. This could be the live schedule. I'm going to copy everything to our what-if scenario. And all right, we're looking at, notice the type in the middle of the screen here showing us or reminding us that we are running a what-if scenario. And in this what-if scenario, I'm simply going to tell PlanetTogether not to consider raw material availability as a possible constraint just by removing the constrained tag. Now here, perform the import and hit the optimize button. So now we have a packed schedule that ignores essentially raw material constraints for the purpose of scheduling. However, you'll notice these little tags, different colors or different tabs here at the top that have different colors. The most severe ones that I defined are red. There are yellow ones, there are red ones, and blue ones as well. So if you wanted to look, for example, at the shortages within 2 days, this is a list and a list I've created before, or an alert that I've created before. So I'm basically telling the system, show me all situations where we are short within 3 days. There's actually 48 of those situations, 48 components or items that have a shortage within the next 3 days within the schedule. A lot of them are raw materials. They start with an RM, and some of them are also make parts. As I click on those make parts, I can obviously do a search here to find any particular part, but I want to focus on those 48 parts that are short within 3 days. I'm just going to click on one here at random. It's basically telling us that this is a steel coil, an RM, raw material steel coil, 18 gauge, 2.2 HDG coil, steel coil. And this table here on the right-hand side is showing us the current on hand to start with. We're starting with 5564, and we're consuming an MRP job on roll 3 is consuming all of what we have on hand. So 5564, bringing us to a quantity on hand of 0. Then there's another job on 12/4 on roll 3, consuming 1401 parts. And on 12/15 is the arrival of the first purchase order. So look at purchase, purchase, purchase. There's a number of line items on the same purchase order that are going to arrive on 12/15. So this explains why when we ask the system to constrain the schedule by raw materials availability, some of the jobs went out to 12/15. But right now, these jobs that are consuming this raw material in this what-if scenario, I'm going to click on the first job, for example, right here. And you can very quickly go from the inventory plan that we were in back to the schedule. So this is where we're producing that lot. Let me click on the next one here. And it is the same one on roll 3. It may be a little further back here in the schedule. So we're comparing two what-ifs. Again, I'm going to show you what this looks like. I'm just going to zoom out to a monthly schedule. So in one case, we have a what-if scenario where we told the system to ignore raw materials, and it's showing us the issues in terms of shortages. And in the live scenario, we deal with reality and present to the user a rationalized schedule where the raw material constraints are actually causing some push-outs here. So we can create as many what-if scenarios as we want. So as a user, as a planner, we can run a live schedule and also run scenarios where we simulate the impact of having a raw material not enough on hand, or changes in a PO due date, for example. Okay. This Gantt chart representation can also be presented to the user in a form, in a simple list. So what you're looking at here is the schedule for roll 1. If I go back to the Gantt chart, I can also do the same for roll 2. Here's a schedule for roll 2. So any way we need the data represented to the user, we can do it. This is essentially the schedule that we have. One detail I talked about earlier, let me zoom in here and focus on those nasty setups. Okay. The third label down here at the bottom shows the setup time and the runtime in green. Setup time is in white for all these jobs. We can clearly see that there's probably some optimization that can be done. If we're in the same, so we're going from die 1 right here on roll 3. We're going from die 1 to die 2 to another job here, which is a little small. I don't want to zoom in, but we're clearly going back then to die 3 and incurring a 1-hour setup. Then we're staying on die 3, which is great. But then we're going, zoom in a little more. We're going back to die 1, staying on die 1. So clearly going from die 1 to die 2 to die 3 forces us to incur some setups. But what if within a day or two we could minimize the setups and tell the system basically to consider setups in its logic? I'm going to show you what that looks like. There's a table you can build on every machine. I'm going to use the roll 11 as an example. And we can define dies and setup times between a particular die model. In this case, from D2 to D1 will take 240 minutes. That's 4 hours. Going from D1 to D2 is also 240 hours. So once those matrices are built, let me look at roll 3. That's the work center we were looking at. There is a die matrix. There's a length matrix. And the length matrix is fairly involved. Thickness, which is also pretty big, and the width. So any state, if you will, or product family that we're producing has a certain set of attributes that once they are defined in PlanetTogether and we ask to optimize a sequence, we can tell PlanetTogether to do that. So right now, these are sliding rules, if you will, that force PlanetTogether, where we define and tell PlanetTogether what to consider in the sequence that we're running. So what I'm going to first do is I'm going to get out of here and create a what-if scenario and create another what-if, and we can create as many as we want. Okay, it'll be, I believe, scenario 17. And in scenario 17, I'm going to change the rules, the scheduling rules, to consider setups. And how do we do that? There is right now only one factor that we're considering, which is the earliest job need date. So at this time, we're only scheduling in order of need date, which is driven by the demand associated with each of these manufacturing orders. If we wanted to also consider setups, I'm going to, use this sliding scale and tell PlanetTogether essentially that we're going to look at delivery, but with a relative factor of about 3 The delivery is 3 times, if you will, more important than saving setups, least setup hours. I'm going to run this, save, go back to the schedule, and look at the Gantt chart, and zoom in a little bit so we can clearly see what happens. And notice over the next 3 days, we have some white labels in the 3rd label row. Some of that setup will disappear or will go away once we optimize. I just finished optimizing. So I don't know if you noticed, but some of these setups were displaced. It went from the beginning of the schedule. We had 3 of them to only 1 of them to be scheduled on the 6th of December. And all setups on roll 3 disappeared except for 48 minutes setup twice on December 5th, which was yesterday. So, and you know, if you can, on a constrained work center, reduce the amount of setups that you're doing, obviously we're increasing the output of that work center. And if it is a constrained work center, we're increasing the output of the entire factory. So this is one example of how PlanetTogether helps companies within delivery dates optimize the sequence of work on critical work centers and produce more with the same labor hours and with the same capital investment, considering obviously raw materials availability. Now what happened also on the screen is a lot of setups were eliminated and some jobs were actually turned from red to green. I'm going to compare scenario 16 with scenario 17, at least on the Gantt chart. So I'm going to flip back to the Gantt chart here. And we actually did have some jobs that were on time or close to being late. So look at the amount of setups or number of setups, especially we're doing on day 1 on roll 1 and roll 3 compared to scenario 17, where we do much fewer, especially at the beginning. We're doing no setups in the first day and a half on roll 1 and very small setups on day 1 and day 2 on roll 3. So this is one example of how PlanetTogether supports the philosophy of maximizing both on-time delivery and output and increasing velocity of products out on the shop floor. Notice also that the metrics, the alerts that I set up to tell me how to compare 2 scenarios. First, those scenarios can be compared using different criteria that your company may want to use. So we have scenario 1, scenario 16, and scenario 17. Let's expand that a little bit. And scroll to the right. So here are my 3 scenarios out here on top. You can see differences in the performance of those scenarios. So we had 4.2 days average lateness in the first scenario, where we accepted all raw materials if they are constrained to push out some jobs. We went down to 0.3 days in average of lateness, down to a little under 0.2 days. So we clearly improved lateness. Also greatly reduced the daily setup hours from the previous scenario, 1 hour in average daily, to less than a half hour, to a little more than a half hour daily setups. Daily production in units, look at this one. 36,000 units on the first scenario where we accept constraints from raw materials. 60,000 to 90,000 daily production in average, just by reducing setups. Other significant metrics that may make sense. Percentage of late jobs was 96% in the first scenario, 85%, 84% in the third scenario. And if you're dealing with such a thing as late penalties on different jobs, late penalties are much cheaper here. So this is a kind of a summary that's customizable to compare one scenario with the next. But we can also set up alerts and look at the number of jobs that are short within 3 days, or overall shortage situations. We're going from 63 with scenario 16 to how many with scenario 17 rather, to how many 64 with scenario 16. So the point here is we can set up alerts and look at data that's customizable to compare different what-if scenarios, depending on the situation that we want to simulate out on the shop floor. Other important critical functionality that we wanted to demonstrate today, the inventory plan to us is our go-to screen where we first ask the system to show us exception messages, right? Here are the raw materials down at the bottom. Here are the finished products for which we have a projected negative on hand, and have all the details that support that. Starting on 12/4, for example, we're starting with an inventory of 4. That's the current on hand. And then we're going to consume 4 of them, then consume 336 of them. Then we're actually producing, see, job material, job product. We're producing 1,020, bringing the inventory level above 0 at 684. Then we're consuming more of them, 340, bringing us with a net balance at the end of the day, at the end of 12/4, to 344. So the question here is, do we want the system to constrain production based on shortages of subcomponents or raw materials, or do you want to have a chance to expedite the schedule that ideally you would need to produce? Okay, so fundamental things that on a day-to-day basis, I used to be a planner myself in a previous life. These are the questions that I ask myself every day, all day, but the information was very difficult to obtain, and more difficult to obtain. Okay, so we saw how what-if scenarios work, the inventory analysis, inventory plot or inventory plan, the Gantt chart, optimization of setups, how do we define setup families, et cetera, et cetera. How does this schedule get published out on the shop floor? Usually we send the schedule by work center back to the ERP system for execution. And that's usually where manufacturing orders, work orders are released, and they're transferred back to PlanetTogether as often as needed, and give a new status from which a new schedule is recalculated, and the clock moves on to the next day, and so on and so forth. So there is a very detailed integration with ERP systems or any system that's in place that has production capacity, manufacturing orders, routing, bill of materials, inventory levels, safety stocks, etc. All that information is defined usually in the ERP system and transferred over to PlanetTogether. All right, so let me get out of the demo and briefly talk about a model that we define as the high-performance material flow, or HPMF model, that has, depending on here at the top, supply chain, and this is, again, we're jumping from the demo back to this model. This is the model that it needs to be in place, in our experience, for PlanetTogether or any scheduling system to drive results. The implementation of PlanetTogether doesn't finish when the data is flowing correctly between your ERP and PlanetTogether. It actually starts when PlanetTogether has the information you need to schedule. We then need to line up the company and the processes from order entry to manufacturing execution, align them with the information we're seeing in PlanetTogether. What good is it to have the perfect schedule created in the planner's office if the shop floor measurements contradict what we're trying to do and actually essentially work on their own schedule? So schedule adherence is very, very important with PlanetTogether or any tool that helps with planning and scheduling. So this is a model. Don't have much time to go into the gory details here, but depending on whether you're engineer to order, make to order, assemble to order, make to stock, there are concepts that we could help you put in place. That's as a strategy, and then the tactics is essentially linking demand management, making sure that you're not overcommitting the plant, that the demand is realistic, aligning procurement or purchasing management, along with production planning, scheduling, and shop floor execution. So that is what we call the three-legged on-time delivery, 95+% on-time delivery, three-legged stool. These business functions, departments need to work together. And it needs to be under an economic value added concept where we evaluate competing projects and efforts. You have limited resources, no shortage of good ideas. This is the best way, we believe, to prioritize correctly and maximize the impact of what you're trying to do. One final note, you may have liked what we talked about today. I just wanted to bring up the services that we offer. Our coaching services are available. And if I take the sports analogy, a coach doesn't play, but it directs, it guides, it aligns, it ensures that, whichever, again, to stick with the sports analogy, that your players are well supported, they're well fed, they sleep enough. So our coaching services are really that. They are based on our experience. We've played this game before. We have been in your shoes. We coach you on aligning your company, your actions, the actions in your company with the strategic vision of upper management. So practically, what does that mean? Well, we have this high-performance material flow workshop, 3 versions of it, and the objective of all 3 are the same. It is to teach your associates how to transform the order-taking to delivery process to achieve high on-time delivery. There is a 2-day version right here, introduction to the concept, to plant ideas and plant the seed in your manager's minds, and the price is included right there. We have a 4-day on-site version, which is a full workshop where we use simulations and games to teach your people that certain things you're doing today are counterproductive or not aligned with your company's strategic objectives. So that is 4 days, still on-site. And we offer the complete workshop implementation strategy, and tactics, where we will adapt the HPMF concept to your company and give you a plan to transform your current processes to the new processes that should be in place. Okay, these workshops are available probably as a next step. We evaluate and demonstrate PlanetTogether as part of these workshops. Of course, if you're interested in looking deeper into PlanetTogether, we're available to do that. We can take your data, put it in PlanetTogether, run simulations, and show you what it would look like. So any way we can go here these are different options. And finally, I want to make sure you see our contact information here, and we'll be happy to answer any questions you may have, any interest you may have in any of the 3 versions of our HPMF workshop in your company. All 3 of those workshops are done on site. So we're not, this is not a exercise or theory. It is practical. We adapt our message to your environment and usually deliver a ton of value just by facilitating the discussion of what you should be doing, what your company should be doing to be better aligned with your strategic objectives. So that being said, Ryan, if you can open the phone lines and open the line for questions.
Yeah, we'll leave it open for a second. We've got some QA. If you guys want to use the QA box, if anyone has a question, or there's a raise your hand feature. And of course, if not now, Scott and Michael are open for an email or a call at any time in the future. But yeah, Michael, doesn't look like we have any questions at this point.
Okay, let's give it another couple of seconds.
Sure.
Any comments, questions on PlanetTogether? Can it work in your environment? I'm sure you're wondering, if and how it could work in your environment. Any questions? All right, going once. Twice. All right, very good. So don't hesitate to contact us. We'd love to hear from you. If this is part of also a series of webinars that we're delivering on a regular basis, anything surrounding planning and scheduling is, we can certainly deliver content and try and educate people and help help companies just align their actions essentially with the strategy or direction and vision for the company. So thanks again for attending this quick webinar. I look forward, Scott and I look forward to, and Ryan look forward to hearing from you, and have a great rest of the day.
All right, thanks, Michael.